Let us now have a look at a very interesting problem which involves two functions, the greatest integer function and trigonometric functions, in particular the cosine function. So, a function is defined as cos of pi square x, where pi square is within the greatest integer function, and plus cos minus pi square again in the greatest integer part times x. So, first thing to be done here is to actually evaluate this function, wherein we have to get rid of the greatest integer function part. So, this is an interesting problem because in some sense we have to evaluate the right value of pi and pi square. So, we very well know that pi is actually the value of pi is equal to 3.1416 and so on, and if you square it, we get a value which lies between 9 and 10, which means that if you take the greatest integer part of pi square, you will get 9, and hence the first part of the function can be written as cos 9x. And similarly, minus pi square again will be equal to minus 9 point something, and therefore, when we take the greatest integer part of that, it becomes equal to minus 10. So, that is the important part to be noted here. And since cos of minus x is equal to cos x itself, therefore, cos, what we get here we have is cos minus 10 times x becomes equal to cos 10x itself, and hence we can write it as plus cos 10x. Alright. So, we have now evaluated this function by getting rid of the greatest integer part. Now, all that matters is to evaluate the value of the function for different values to be given for the x. So, the first thing we have to do is for evaluate it at pi by 2. So, what happens here, we have cos 9 pi by 2 plus cos 10 pi by 2, which is equal to cos 5 pi. Now, the remaining part of the problem is just makes use of whether we know the values of cos at certain important angles. So, what is this cos 9 pi by 2? We know that any odd multiple of pi by 2 cosine becomes equal to 0, and therefore, this is 0 plus, and an odd multiple of pi cosine takes the value minus 1, and therefore, we have minus 1. Similarly, here what we have is cos 9 pi by 4 plus cos 10 pi by 4, which becomes 5 pi by 2, and again it is just a matter of computation, and you will get the answer as, so this can be written as 2 pi plus pi by 4, and therefore, this becomes 1 by root 2. So, this the remaining part of the problem is actually standard calculation involving trigonometric functions. So, nothing challenging about it. So, the last part we have cos 9 pi plus cos 10 pi, which becomes minus 1 plus 1, which is equal to 0, and finally, we have cos 0, which is equal to 1 plus 1 and becomes equal to 2. So, this was a nice problem because of the initial part which made use of actually computing the value of pi square and then making careful use of the greatest integer function part. The remaining part of the problem was straightforward.